In this video, we're going to talk about area. Unlike perimeter, area is how much, whatever that means, is inside. For example, if you have a rectangle and it is 2 feet by 3 feet, we want to know how much is inside here. Not how much is along the sides, but how much is inside. It's very important that you understand this. If this distance is 2, well then if I cut it in half, each piece would be 1 foot. Let me do that on the other side, of course. If that whole distance on the right side is 2, if I cut it in half, then this piece would be 1 foot, and this piece would be 1 foot. The bottom is, or the top is 3 feet. The bottom and top are 3 feet. If I cut it into 3 equal pieces, then this would be 1 foot. The distance from here to here would be 1 foot, and from here to the end would be 1 foot. Now, if I actually cut the 2 feet in half, and I cut the 3 feet into 3 equal pieces, it may not look like what I'm about to say, but let my diagram go, please. This is 1 foot by 1 foot by 1 foot by 1 foot. This here, it's 1 foot. This here, it's 1 foot. This is 1 foot. This is 1 foot. We have 6 of these. We have 6 of these. Sorry that the middle ones look bigger. We have 6 of them. 1, 2, 3, 4, 5, 6. Now, we have this definition. If something is 1 foot or 1 unit, whatever the unit is, by 1 unit, we say the area is 1 unit squared. In our case, 1 square foot. We can write it as 1 square foot, or 1 foot square. This is the definition of 1 square foot, is how much is inside here. That is the definition of 1 square foot. If this really was 1 foot, and this really was 1 foot, so we have a 1 foot by 1 foot area. 1 foot by 1 foot. How much is in here is 1 square foot. If you went to the carpet store and you said, give me 1 square feet of carpeting, this is exactly what they would give you. Now here, that area is 2 feet by 3 feet. It's 2 feet by 3 feet. By means times in this case. We are multiplying 4 things. This, and that. Well, if you multiply the 2 and the 3 first, you get a 6. And then you multiply foot by foot. Just like 5 times 5 is not 5, foot times foot will not be foot. 5 times 5 is 5 squared. So you get 6 square feet, which makes sense. We have 1 square foot here, a second one here, a third one here, a fourth, a fifth, and a sixth. We literally have 6 square feet. So if you had a 2-foot area, or 2-foot by 3-foot rectangular area that you wanted to carpet, you would need 6 square feet. If you went to the store and you bought 6 of them, the first one would go here, fit right in. The second one would go here. The third one would go here. You get to choose where you put it. The fourth one you can put here. The fifth one would go here. And that sixth one would go here. And you carpeted the whole area. Notice it had absolutely nothing to do with the perimeter. We never added the perimeter. We never talked about it. We just said it's 2 feet by 3 feet. That is area. Now, just to make a comment or just to talk about something, when you have a circle, they talk about square units, whether it's square inches, square feet. Well, one reasonable question would be, but a circle is round. How do you end up with square feet? Well, let's imagine this is 1 square foot. And then you have a second and then a third. And here you have a fourth. Oops, you have a fourth and a fifth and a sixth and a seventh and an eighth and a ninth and a 10th and an 11th. Now, if you, and suppose that the area, so we have 11 so far. Suppose that the area of that circle is 20 square units. Again, this is 1 unit by 1 unit, each of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Now, here's the thing. If you took a pair of scissors and you say, carefully cut out this piece, and then, I don't know, you carefully cut out that piece, and you can even cut this one this way, and then you cut out this piece, and then you cut out this piece here, and this little piece, and this piece. If you took, remember, we have 11 square units so far. If you took these pieces, and you cut them up very carefully, don't have anything left over at the end, you can, if you do a really good job, you'd be able to piece together 4, 5, 6, 7, 8, 9. And if you have 11 square units and you add the 9 square units, since we're adding, not multiplying, you'll have 20 square units. Okay, so this piece plus this piece plus that piece plus this here plus this little piece plus that piece, if you cut them up and you pasted them together, you will literally get 9 more squares. In fact, if you took the whole circle, I don't care how you cut it, but if you took the whole circle, you will be able to cut out 20 square units. If that is the area, you'd be able to cut out 20 of these. 1, 2, eventually up to 20. So even circles and things that, you can talk about the area of a pond. This area is, I don't know, 30 square feet. That means if this is a square foot, 1 foot by 1 foot, you can cut this in a way such that you will get 20 of these. You're gonna have to piece things together. You're not just gonna be able to cut out 30 of them. Okay, you're gonna maybe be able to cut out 12 or 18 or 25, but the last 5 is gonna be like this. It's gonna be where you're gonna have to cut and piece them together. But if you do a really, really good job, you'll get 30 of those square feet. It's mind-boggling, isn't it? Okay. Let's talk about the area of a triangle. The area of a triangle is 1/2 the base times the height. If you have a triangle like this, and you choose to call the base that distance, well, you get the height by going to the opposite vertex of the base and coming straight to the base at a right angle. That is the height. And the area is going to be 1/2 base times height. If the base happens to be 8 inches and the height is 6 inches, then the area will be 1/2 times the base, which is 8 inches, times the height, which is 6 inches, while 1/2 times 8 is 4, times 6 is 24, times inch, which is square inches. You can have 24 square inches in here. Now, it can be proven that what I'm about to draw in green, the area in here plus the area in here is equal to the area inside the triangle. That green area is equal to this area. So the area of that square, this was the area of the triangle, the area of, I should say, rectangle, is the base times the height, which is 48, inch times inch, which is square inch. Now, if you happen to take the 48 square inches and divide it by 2, you will get 24 square inches. And when you divide it by 2, you should get the area of the triangle. Because I said that this area is equal to the area in red, the area inside this triangle. If you know the area of the whole thing, 48 square inches, divided by 2, divided by 2, and you get the area of the triangle. So yeah, you can get 24 square inches from a triangle. It doesn't look possible, but it is. Again, here's one, here's the second one, maybe a third one, a fourth one, maybe a fifth one, a sixth one, a seventh one, an eighth, now maybe 9, and that's probably it. Well, it turns out that this piece and this piece and this piece and this piece up here and this one and this one and this one, well, I said 9, so that leaves 15. I can get 15 square inches out of this. I just have to cut it up. It's not going to be easy, but you can do it. I guarantee you. And if you can't, well, it's because you're not real good in cutting. I mean, realistically, I probably couldn't do it either. But in theory, you can do it. Otherwise, you can talk about square inches for circles and triangles and things like that. Okay, let's do a couple of more problems. What would the area of this be? Suppose you have something that goes like this. And everything is right angles. Nothing bizarre is going on. And I don't know, maybe this is 8 feet and this is 15 feet. And this is also 15 feet. And the 8 feet meant that distance. And that's all you have. And I guess this is 7 feet. 7 feet. Okay. Now, we only know how to find areas of rectangles. So, I'm going to draw this again because there's 2 ways of doing this. I'm going to draw this one again. To the best of my ability, they're exactly the same. 15 feet, 15 feet, 8 feet, 7 feet. And we could since this is not a rectangle or even a triangle, we know how to find the area of a triangle now. Maybe we can split it up into a triangle and a rectangle, or 2 rectangles and a triangle, or 2 rectangles. For example, if I just go like this, then this piece here is a rectangle. Let's call it rectangle number 1. And this down here, it's a rectangle. Let's call it rectangle number 2. Now, on the right, I could have partitioned it this way. So this piece here is a rectangle, and the rest is also a rectangle. Call it rectangle 2. And we'll compute the area for both of these, and we'll figure out if we get the same area. Now, since this is 8 feet, I know that this piece is 8 feet. That is, well, if this is 8 feet, then this is 8 feet, okay? But I know that the whole thing is 15. So then this piece that isn't marked must be 7 feet, because 8 plus 7 gives us the 15. Okay, now I know that this whole thing here, this whole thing is 15. And I'm told that this is 7 here. That means this piece is 7. Well, that tells me that the rest must be 8. Okay, so let us find the area of region 1. Well, region 1, that's a simple one. It's 15 feet by 7 feet. It's 15 feet times 7 feet. Just for the record, this is 15 times 1 foot times 7 times 1 foot. Just like x is 1x, or maybe I should say 1x is x. 1 foot I can write as just foot. Okay, 15 times 7, I happen to know that. It's 105. And foot times foot is square feet. So the area of region 1 is 105 square feet. What about the area of region number 2? Well, okay, so this is 8 feet by 8 feet. It's 8 feet by 8 feet. 8 times 8 is 64. Foot times foot is foot square. So let's call it a total. It's going to be the sum. 105 plus 64 is 169 square feet. Now to the right, I have the same figure. I just partitioned it differently. Now, same argument over here. This is 7 feet. Just like I said, it was 7 feet on the left. Okay, so the area of region 1, well, that's 7 feet by 7 feet. Okay, 7 feet by 7 feet. We get what we get. 7 times 7 is 49. Foot times foot, foot square. The area of region 2. Well, that's 8 feet by 15 feet. That's 8 feet times 15 feet. I happen to know that 8 times 15 is 120. And foot times foot is foot square. Now, if I add these two, the total area would be 100, so I add these two, 169 square feet. And let's see, look at that. I had the same answer when I did it with different partitions. It's not gonna matter how you partition things. Let us do one more. Almost exactly the same picture. We have something that goes like this. It goes up, but we're missing the corner. We're missing that corner. And I tell you that it's 4 feet only up to here. This is 8 feet. This is 3 feet. We have 5 feet here and 9 feet up to here. 9 feet. Okay. So there's a few distances that we don't have that we're going to need. We're actually going to need that distance, this distance, and that distance. And in fact, we're not going to be able to do it unless we're given this distance here. This distance is 2 feet. Okay. Now, how can we partition this? So, we have just rectangles or triangles or a combination of both. Well, first, let's make believe this area is actually included. So I can do it two ways. Well, actually one way, one friendly way. I can do this area, that'll be area 1, and then what's left over, this piece here, that will be area 2. But then, let me just erase this here, and then I'm gonna, let's call that, I don't know, area 3. Then I'm gonna have to subtract area 3, because area 1 includes that triangular region that isn't there. It includes the triangular region that isn't there. How do you like that? It includes something that isn't there. But it's helpful to be there. Well, I guess it's helpful to be there because if I put it there, then I can figure out the area of region 1, which includes this triangular region. Okay, enough talking. The area of 1, well, this, I'm going to have to erase this in a moment. Well, here. This lens here, well, this piece is 3 feet, it says so here, and this piece is the same as that piece. So it's 3 plus 8. 3 goes up to here, 8 is the rest. So that's 11 feet. And it should say feet, I'm sorry. So it's 11 feet by 5 feet. 11 times 5 is 55. Foot times foot is square foot. Now, what is the area of region 2? Well, that one's easier. It's 2 feet by 8 feet. Or 8 feet by 2 feet. 8 times 2 is 16. Foot times foot, foot square. Now, if I add this, I get 71 square feet. But, okay, so what I found all the area I wanted plus this area. But I don't want that area. So now I have to take it away. What is the area of that triangle? Well, I know is 1/2 times the base times the height. That I do know. Now, this piece across here is made up of 5 feet. 5 feet go between here and here. And since this is 2 feet, the rest is 2 feet. The whole thing is 7 feet. Now, since this piece in yellow, which I'm highlighting, is 4 feet, I know that, it says it right here, then the rest must be 3 feet. Okay? So we'll call that the base. The base is 3 feet. Now what's the height? How long is this piece? Well, remember, this whole thing was 3 plus 8 or 11. Since this piece is 9, then that piece must be the remaining 2 feet to get to 11. So we're going to remove this area, which is 1/2 times the base times the height, which is 2 feet. Well, half of 2 is 1, times 3 is 3, foot times foot is foot squared. So we have to take away 3 square feet, and we now have the total area without this triangular region. We have the total area now. Okay, so if you went to buy carpeting for this room, you would ask for 68 square feet. You say, can I please have 68 square feet? And if you cut it nicely, and you're not worried, and you should be worried about this, but you're not worried about cutting little pieces to make squares, or to not, well, actually, you're going to have it in squares. You're going to have to cut the squares so they fit like that. Okay, but if you don't mind doing that, you would need exactly 68 square feet. Okay, that's going to complete this section on areas. Remember, sometimes you want to add extra area. You add on extra area. That way you can get a nice rectangle plus another rectangle, and then at the end, so we found the area of those 2 rectangles, and then at the end we took away the area of the triangular region. Many different ways of doing things. Sometimes you add extra stuff and then you take it away. I bet there'll be times you take away extra stuff and then add it back. You have to be clever. There's not just one solution. You have to figure out your own technique.